Welcome back. Now, let's put all of this knowledge to work, literally. So here are 3 worked example questions being solved step by step. Just exactly the same way your physics examiner expects to see them. So watch carefully because every step matters. Here is question 1. A football of mass 0.45 kilograms is kicked and moved at a velocity of 12 meters per second. Calculate its kinetic energy. So let's look at the step. Step number 1. Write the formula. Kinetic energy, that is Ke equals 1/2 times m times v squared. The second step is to substitute. Kinetic energy equals 1/2 times 0.45 times 12 squared. So 12 squared is 144. And the final step is to multiply 1/2 times 0.45 times 144, which equals to 32.4 joules. So here is a memory tip for kinetic energy. Say it out loud. Half my velocity squared. Half mv squared. That is, kinetic energy equals half mv squared. Say it 3 times and it is locked in your memory forever. Kinetic energy equals half my velocity squared. So here is the second example. A climber of mass 65 kilograms stands at the top of a cliff 25 meters above the ground. Calculate the gravitational potential energy stored in the climber. Take G as 10 newtons per kilogram. So step number 1, you write the formula. Gravitational potential energy equals to the mass times gravitational field strength times the height. Step number 2 is to substitute. Gravitational potential energy equals to 65 times 10 times 25. And the third step is to calculate 65 times 10, which is 650. Then 650 times 25. This equals to 16,250 joules. Now, here is the memory tip for gravitational potential energy. So gravitational potential energy, GPE, equals to my great height, MGH, my great height. Imagine yourself standing on the top of a skyscraper. The higher you climb, the more gravitational potential energy your body stores. Yes, my great height equals MGH. So question number 3. A marble of mass 0.02 kilograms rolls off a table 2 meters high. Assuming no air resistance and treating this as a closed system, what is the marble's velocity just before it hits the ground? So step 1 is to calculate gravitational potential energy at the top. So gravitational potential energy equals 0.02 times 10 times 2. So it equals 0.4 joules. So step 2 is that in a closed system with no air resistance, all of the gravitational potential energy is being converted to the kinetic energy at the bottom. So the kinetic energy equals to 0.4 joules. Step 3 is to rearrange kinetic energy equals half mv squared to find V. So V equals the square root of 2 times kinetic energy divided by m, the square root of 40, which equals approximately 6.32 meters per second. So here is the truth that most physics textbooks gloss over. In the real world, a perfect closed system is almost impossible, yes. Every real system leaks a little energy. Every thermos loses some heat eventually. And every sealed container is not perfectly sealed forever. So this is the crucial distinction between theory and experiments. In physics, we often assume ideal condition, a perfect closed system. So this is to enable us simplify our calculations. But in reality, entropy ensures that energy always tends to spread out. No system is truly perfect, no. So this spreading out of energy, this tendency towards disorder, is called the entropy. And the second law of thermodynamics states that in any real process, entropy always increases. Energy always tends to become more spread out, more dispersed, and less useful. So this is why your coffee gets cold and never gets hot on its own. That cold cup of coffee, that is the second law of thermodynamics in action, right in front of your desk. You see, physics is not just abstract. No, physics is not abstract. No. It is happening to you, around you, every single second of every single day.